Good morning. See if you can wait maybe 30 seconds. People filing in. It's kind of early. For those of you who were there was a party yesterday, and so maybe everyone is still trying to wake up. Let's go and get started. My name is Ralph Krohn. Hello. I lead the design team at Surface, and today, this morning, I want to talk a little bit about product making. So that's my session. I think outside it says design matters, but I think what we've done is the way we think about making products is, or the way we think about design is putting design in the larger context of product making, and that's my talk. And to kind of get warmed up a little bit, I want to share this image here. I put it on this morning because I was thinking when this is the 1974 VW Golf was sold here as the Rabbit, and this was in 1974. I was 6 years old. So I grew up in Germany, as you can hear my accent. I also grew up in the city of Wolfsburg, which is the headquarters of VW. So everyone I knew in my family worked at VW, and one of the advantages is that you get a car to a discount back then, and every year we had a new car, and then after a year we would sell it for a little bit of profit if you take care of it, and so on. And so we would have Beetles, VW Beetle, and we would, as in Germany, they have long summer vacations, and every summer we would take the rear seat out, put luggage in, a tent, and then an inflatable mattress, and that's where I would be on. There were no seat belts back then. And then we would drive to Spain, usually for 17, 20 hours, and then stay there, for 3 weeks and coming back. So going on vacation was a big thing. And then the VW Golf, or the Rabbit, how it's called here, came out, and it was so different. The engine was in the front. It was designed by Italian guy, Giugiaro, of Italdesign. And one of the things that this car did was, it had roughly the same size as the Beetle, but you could flip the rear seats over, and then you could turn the rear seats into a huge trunk, and you could go to the German Home Depot and get your paint buckets, or you could go on vacation and you could do all kinds of things. It was a radical shift from, it wasn't air-cooled, it was water-cooled, the engine was in the front, there was a front-wheel drive, not a rear-wheel drive. And as a kid, I would sit in family gatherings, and everyone would talk about cars. And this was this huge discussion and debate, and people thought, oh, it was ugly because it didn't look like the Beetle, and then all these things. And the first generation, they came out with disc drives if you bought a GTI, and they would squeak. You would come to a stop at a stoplight, and they would squeak, and there were big complaints about this. And then a year later, people bought the car, and then 2 years, 3 years later, it was very popular, and it became the #1 car in Germany. And it's inspiring to me because these guys back then, there were car categories, and they came up with this car, and it was a radical shift. They invented a new category. There was a hatchback, a compact car that you could transform and adjust to your needs. And when I look at design, it's many people think our design is making things beautiful. I think a beautiful product is a result of thinking about stuff maybe deeper than just the skin level. And this is a great inspiration for me because this car changed how people interacted with the car. And whenever I design a product, I think this is a great bar and inspiration for me. So what does it mean to Surface? I want to talk a little bit about what we do at Surface, how we think about product design. I'm an industrial designer. I don't understand anything about programming, but I spent my time in Germany studying tool making, and then I studied industrial design, and then I came through a couple of places into Microsoft. I started 8 years ago at PC hardware, designing mice and keyboards. You guys might have seen the mouse that folds like this, the Arc mouse. That was my first product, and the last one was the Arc mouse that folded flat, and all the products in between. So going back to the VW Golf analogy, right? So a product, it needs to be a great mouse, needs to fit in your palm, but then you punch it flat, and then you can stick it in your pocket, right? So it transforms. So there's some sort of a pattern there if you want. So I want to talk a little bit about Surface, the past, the now and the next. And so to give a little bit of context. About 4 years and a bit ago, we started out being called into this project, and it wasn't called Surface. We gave it a code name, but we were 12 people as we started. 12 people. Surface started with 12 people. There was Panos, and there was the people who now lead the engineering teams, and a few others, and then myself. And it was a group of people who got sent on the mission. Hey, let's go and make hardware for Microsoft. And then in my mind, I was like, yeah, right. Microsoft doesn't make hardware. Microsoft makes software, and so on. And so it was back then. There was this kind of this concept of how we go about our business. And then we set out doing this. And in the first months, I was like, this is not going to be real. But then as further we went down, the development path, the more real it became. But it was 12 people setting out making products. And now so many months and so many people later, we know, of course, a much larger group. There was this insight that we gained as we started out in a very, very small group and setting kind of our culture and the rhythm of how we make products. And the fundamentals is, products are a reflection of the people who make them. And I think this is if you pick up any product and then just imagine, how much passion someone must have had, how much care someone took or not, and imagine the meetings that led to kind of this feature. Imagine the meetings that led to that feature. And at the end of the day, it is all about the people who make the product that then the product quality reflects, to that fact. And it is not only the designers, of course. It's the designers, it's the engineers, it's the marketing people, it's everyone, who is part of creating that culture. Because if you step back from this, it's really the way people interact with each other, the culture that you create in that group that allows you to make certain products. And so that's what. That was the big insight. And so I call it the culture of product making. And how do you form a group? The bigger project than making the first Surface was forming a group of people that were passionate about making a great product and not passionate about any other thing. We were very, very product focused. And so here's a snapshot of year one. A couple of things are blacked out because I think some of the things are still cooking. But here you see a group of people. We were in the basement of a lab, and there are designers and there are program managers, there are engineers, and we would meet every day for many hours and just go and talk about the product, right? And it's not about the designer sitting in an ivory tower and letting out the napkin sketch and tell the engineers let's go and make it and have enough power and then everyone needs to go and do this. It's really getting a group together and figuring out what is the right what's the right vision and what is the right product. Part of doing this and building a group of product makers is we grew a team, homegrown, everything. We have everything in house. Everyone there's all the designers are Microsoft employees and working on our campus together with the engineers. Everyone that we have, we built this group, on our campus, having everyone in one big space in order to have these conversations, right? So if there's an idea, you need to have very small distances of you need to walk around the corner and talk to your colleague about this idea, and then things get sparked up, and then you go about making the product, and having everyone in house is critical to make that happen. So this, if you take a good look, this was the first. So when we started out, we made tablets, and we made a bunch of tablets, and we made these. We call them industrial design models. They come back and they look beautiful, and just like the real product, and they're just filled with plastic. They don't work. And many of these models, they look just great. And we felt, they were just another tablet. And we continued, prototyping in our small space. And at some point, there was this idea, hey, let's go and glue a kickstand onto the product. And then this was the model that we made. There's another shot of it, a little close-up. And you see how poorly it's made, right? It doesn't really look good. It was done on a laser machine. We glued some magnets in the bottom and used Scotch tape and electrical tape kind of to build this hinge of the kickstand. But this was the model that we back then presented to Steven Sinofsky, who ran Windows and who was our executive sponsor. And this was basically the model that got us funded. You know, we didn't have a presentation. We just brought this model. And in fact, the white cover that you see is a cover that was magnetically held in, that you could click in, and the kickstand opened in one position, very close to the final product, the angle of the final product. But it illustrated the idea, almost like the VW, Golf, where you say, hey, you can flip the rear seats over, and then you have a big trunk, kind of like this. And immediately we felt there was something in this pretty poorly made model, but the core reflected a lot of what Microsoft was about, right? It was not all of a sudden, it wasn't just a tablet that you could use to browse the internet with, but you could some kind of transform it and make it useful, get stuff done, and then you would fling things back, and then you can go and consume or browse the internet or whatever you want to do. And the funny thing is that at this point I thought, oh yeah, this is a good idea, and we are almost done. And realizing, in hindsight, what a mountain of work it was that we were in front of, that we had to go and solve. When we looked and so we had this concept and we looked at it and said, why would we make hardware, right? What's the advantage of making hardware? And the thought we came back with was people want to get to their digital stuff, and they want to get to their digital stuff if they're at work, if they are, if they are like someone in the mobile workforce, or they sit in the office, or they sit on their couch, and the stuff they want to get to needs to conform to the situation where they're in. And we thought of hardware as a stage for software, which means the reason to have hardware is to get you to your digital stuff as easy, as smooth, and convenient, and fast as possible. And therefore, we wouldn't design something that looks just amazing with a lot of chrome and things around it. Everything that we wanted to design wanted to go and dissolve away, and to make room for the software experience that you should have. So, we thought of it as a stage, and kind of in a very primitive way, how we always start out projects. We collected images of stages to just visualize, because, we talked to, on the engineering side, or to us as in the design team, we said, the act, the show is the software, and the hardware is all of what you don't see in this picture, right? It should just dissolve away. Just like the keyboard, when you don't need it, you fling it, to the back, and it should just not bother you, right? Or if you add stuff to it, if you add a kickstand, and if you don't use it, you shouldn't feel it, right? The kickstand should kind of dissolve away, instead of like a Swiss Army knife. When you add the tool, it gets bigger. You have a bigger object, and we wanted to achieve the opposite, just like having things fold away. So we have a lab with our group. Our model shop got built up, and we added a bunch of 3D printers. And the idea here was rapid prototyping. So these printers you might have seen, you mock something up on your computer and then send it to print, and within hours, you get something physical that you can hand. And you can prototype and see how it feels. You can prototype different geometry, different weights and sizes, and so on. And we did hundreds of those. If you have an idea, good, let's go and print it and let's check it out. The idea of rapid prototyping for us is, fail fast to succeed sooner. We had 1,000 bad ideas, or maybe 2,000 bad ideas, and then once in a while there was something we go like, oh, this is kind of nice, and let's go and keep that. The disadvantage was the small room we were in. We filled out with models and cartons, and it was always a big mess where we worked. But they were kind of useful, so we used them almost like as 3D drawings. When we started out Surface, Windows 8 was about 6 months ahead of us. We had no idea how this software would perform. And here's a snapshot of a model that we made, and we got some printouts, and we tried to figure out, okay, how does the swiping work? Back then, there was the mandate of having a 16:9 aspect ratio. That kind of came in from the Windows team, and we tried to get to terms with it. So how would you interact with a device like this, and what is the right screen size? So we went through this. The other part was, okay, now we have an idea. Now we know what kind of software works for it. We have a vision, and we sat in a meeting. And there's a gentleman who runs my materials team. His name is Alec Ishihara, and he said, "Oh, we could injection mold magnesium, and then we have kind of a watch quality finish." And when he said that, everyone wanted that. There was an image in our mind's eye of like, oh, watch quality finish. That sounds so awesome. Yeah, let's make this. And magnesium was a great choice, and we studied it a little bit. It gives you about 35% less weight than aluminum, and so you could then go and make at least the structure lighter than other people make their tablets, and have a strategic advantage. It was just the problem was that the investment to go to magnesium was enormously high. But the way kind of we our team behaved was like, okay, let's go and master these materials and do this. And so watch quality finish, when it first came out, looked like this. It looked really crappy, and I remember when this first part was delivered to us to Redmond, and I got a phone call. It's like, yeah, the first parts are here, and they look okay. And so then it was like we walked into this meeting. Someone pulled out of an envelope, and I remember the emotion I had of this. Like, oh my God, this is going to be a longer process. And that year, I think I flew to China every month or so. This is a shot that we had at the tooling shop. So we injection molded magnesium, and this was the largest injection molded part of magnesium that was done at this time. It is an extremely hard process to injection mold magnesium. Later on, there's Vineet who's going to talk a bit deeper about the manufacturing side. But as you know, magnesium is very corrosive. It reacts with oxygen immediately. So we had to go and figure out how to suck the oxygen out of the tool, and how to mold this piece. So all in this large form factor, there's molding pressure, there are mold release agents. That was all innovated on. So the depth in innovation that we did in the first round of Surface was crazy. We have IP on the tools that make the Surface. This is how deep we went in with our manufacturing engineering group, and it was hard. But the other thing that we found was the people that then came to our group and worked with us, they were as fanatic as the industrial designers, right? As the group of 12 that set out, said, hey, let's go make the best product we can make. And what formed was not only the first generation of Surface, what also formed was a group of people who went through some long working hours and together and formed as a team and set kind of the culture of when we talk about perfect products, right? So nothing is ever perfect, but we run to this kind of asymptote and try to get as close as possible. And good enough is never good enough, right? And so that kind of culture grew when we did this. And so the first generation of Surface happened, as you know. Then we did the second generation of Surface, where we it's always like you work on one generation and then you get insights of how to make things better, but there are always ship dates, right? So you ship the first generation while you then start kicking off the second generation. And then sometimes you get an idea that is so complex that you need to develop it over a bunch of generations in order to make it really work. And one of those ideas was the continuous kickstand that you see in Pro 3. The insight that you want to have multiple kickstand positions or you want to have it continuous, we got relatively early. It was just super hard to make this part reliable in such small envelope. And so that, some of these things, they just have a very long innovation path and they go on in parallel. Let me have a sip of water. Excuse me. So in this early or kind of first stage of Surface, growing, learning, listening, building a team, those were kind of the pieces that went on. And then snapping to the now, I have so we've been moving. When we started with a small group, we were in one room, and we constantly moved to other spaces because we all constantly outgrew the space we were in with the people we hired and the 3D models that were in our way, and we had to kind of go in and get more space. And I have oftentimes when people come to our place, we show them where we live now. There's this awesome building that we took over. It was the first it was the Microsoft library. It's a space that is about 100,000 square foot. And if you imagine we are in Redmond. There's one office building that we have where people have their offices and we have our meeting rooms. And then there's another building, 100,000 square feet, that houses our design studio, our prototyping lab, and all our testing facilities. So that's a space where all the talents in our group can come together and prototype and work together. So if you come to Redmond, some of you people have and visit this building. It's quite impressive. And so I thought, for this talk, what could we do? So there's this guy, Brian Townsend, who does our videos and animations, and I asked him to buy a video drone. And last week we flew around the campus. It was quite nice weather, and we put this video together. Hope we have sound, and it gives you a little bit of an introduction of how we work now. And so that's kind of the space we live in now and design our products. The moment you bring physical representation of your idea to a decision-making table, everything changes. To make a product, you really have to engage in a whole different level of problem solving. And no product is ever designed by one person. We've been able to bring all of our diverse talent across engineering and design and prototyping under one roof. It enables inspiring each other from your different ways of how you look at the world. An engineer can inspire a designer, a prototyper can find the next engineering solution. And by our working together, we dissolve into this group of product makers. We have to look beyond our disciplines in order to push things further. Because only if you look beyond your discipline, you understand that the greater goal is not only to be the best in your discipline and win a design award or something like that. The greater goal is to make a product that people love. Yeah. It's a big place. It's a super awesome playground. Serious one though, and it's kind of nice to see where we've come from, right? So from like a handful of people with an idea, and working at a place like Microsoft with so much passion and trust to kind of see what be passionate about the vision that we created, and then go and support a handful of people into the group that we are now. And so this is a massive building. It's not a hobby shop, right? So we are in for for a long term here, and you can just imagine all the people who work there. There's lots of stuff that we can come up with. But it is a lot of fun. So where we went from the past to the now, and you have you have Surface Pro 3, and it's a big success for us, and it's super nice for me to see, people outside of Redmond, using your device. And at first I thought, hey, are you at Microsoft? But no, they just bought the product because they like it. And it is such an interesting insight that by keeping the vision, because we knew it was the right vision for us to pursue, but refining the recipe of screen size and weight, and then pushing innovation further forward, you all of a sudden reach a sweet spot that resonates with people, right? And so that's kind of cool. Here's a quick animation of the key things that we changed from Pro 2 to Pro 3. And so when we designed the Surface Pro, there were immediately fans. It was even the first generation was rather heavy and a bit clunky, a little tank. But people loved it because it ran real Windows, and they could do things with them that they couldn't do with any other machine. It was a little powerful machine, and it was. And it solved some serious, user needs, and we were inspired by looking at people taking them out. And so when we designed Pro 3, if you take a look at, it was this thing went from 13 millimeters, and we pushed Pro 3 down to 9.1 millimeters, right? And so the reason why we could do this was we made a larger screen and so on. But it actually, the difference is profound, right? It went from something that looked like a little tank, like a stealth bomber kind of indestructible piece, to something that is really more in the consumer electronics space. People really want to have it, instead of they understand the need and then they buy it. The other thing that was important to us that we found out was we increased the screen size, from 10.6. We went all the way to 12 inches, and that was a huge change for the people's experience. That extra real estate gave you just enough, pixel ergonomics in order to go and run, real programs, right, instead of apps. But it kept the product small enough so it was easy to carry. It's very close to kind of a European A4 or a US letter format, and it kind of fits into briefcases and things that people already carried around. And because it was slim, because it had a bigger surface area, we could make it slimmer because we could kind of spread out the battery across a larger surface area. And so you had then a product that was more powerful, and it was even lighter, and so on. And it was thinner than its predecessor, and all of a sudden the recipe was right. The other thing that we did with this product there was an insight. You've seen the image I showed before, the injection molding magnesium, and we really pushed the limits on injection molding magnesium, literally, because we couldn't make a 12-inch size magnesium injection molded piece, because the physics on how you control the tooling and the injection molding process were just at its limit with its predecessor. So it kind of pushed us to jump into CNC machining the bucket or the chassis from one bit of magnesium, and that had the challenge was that we had to go and invest in the massive amount of machines in our manufacturing, and that required another commitment, on the Microsoft level to go all out and get, and believe in this product. The advantage was that if you CNC machine, if you tool stuff, you always have to get at a point where you say, okay, now it's ready, we have another engineering validation unit, let's go and release for tooling. And then you sit there for 10, 12 weeks and wait for the tools to be done, and innovation kind of stops. You can think about what you will do when stuff is back, but stuff is not going to be back for another 12 weeks. And if you think of the iterations that you need to make a product perfect, if you always have 10, 12-week blocks in your development process, you're wasting a lot of time. And so with going to CNCing there, we got rid of this waiting time. We could, we have seen the big prototyping facility that we have now. We have the ability to CNC machine production level units right next to the design studio and figure out, how this change would impact the performance, right? So an example is, there's this vent, the perimeter vent that runs around your surface, and relatively late or pretty close to production time, we looked at it and I was like, oh, I don't like the spacing of it, it doesn't look right. And we changed it. And we could then machine a couple of units within 2 days in our shop and then get them back and look at them visually and then test the performance, right? It's impossible to do if you have to commit to a tool and then, sorry, tools are released, there's nothing you can do, and we completely eliminated that process, and it was a huge advantage. So we can now pack in more and more iteration cycles in a product development cycle in order to perfect what we want to do. And if you ever design products, if you get another iteration cycle, that's always awesome because you can always push to the product to the next level. And here's an image I really like aesthetically, and I'm not sure how close you guys are to product development, but I guess I heard someone saying with code it's the same way. So if you look at the outside of Surface 3, looks really nice. The inside, and this is actually not Pro 3, this is Surface 3. But if you take a look at the inside, the geometry that was created, it's not that we industrially design from the inside and make the product purposefully beautiful from the inside. It is just the fact that our engineering team and our design team work so closely with each other that the products reach a level of fitness, meaning the performance to weight, the ruggedness to weight, and all these elements get to a level of balance that that reaches a geometry like this. It's at a level of engineering that we couldn't make better, right? At this point, we had no idea how to make this part better, and then it was finally right. And what does good enough look like when we say, let's go and ship a product? Good enough is for us when we've pushed every lever and every limit, and finally something that started primitive went to a long time being complex and too much and not quite there yet. And then if you push things hard enough and have passion enough, then a product turns into the space we call simple. Things all of a sudden become easier. You get more performance and things get lighter. And stuff becomes easier. But just you have to push through this. Through this big mountain of stuff is still too complicated, not good enough. Let's go back. One more iteration cycle, not good enough. Let's test it, and then you land at something. And you say, okay, now we can go and ship it. And so that, for me, this image represents this. On Pro 3, of course, all the electronics, all the architecture inside, we've all engineered in the same building that you just saw. In order to pack, powerful processors in there, we had to invent cooling systems. Thermal engineering needed to happen on a big scale in order to control the heat that these processors would create inside, but also in order to give someone, a workstation that's powerful enough. So a mechanical engineering team always designs the next generation of Surface Pro on the previous generation of Surface Pro, and that's kind of one of the things that and same thing for the designers. We design our CAD programs run on surfaces, and we don't get the Core i7s. We usually get like pre-released units, and they run. The specs are not top of the line, but these machines, they pull their weight, and it's quite awesome, to design the next generation on the previous one, and so we take a lot of pride in that. So I talked a bit about the innovations that take the insights that you get while you design a product, but they're just so big in terms of complexity that they take multiple generations to implement. And for us, this was the continuous kickstand. I remember we were like somewhere in the middle, maybe not quite on Surface 2, where we played around with 2-position kickstands, and then we it really needs to be. The real solution is to just go and have a continuous one. And then we started looking into this, and a team went there, and it's not easy. And so it took us all the way to Surface Pro 3 to implement this. Here's an animation on how this actually looks inside. This is the top of the kickstand, and inside there's this hinge that has that that has a friction element that grips around a cam, so that you can imagine the torque that you get when you open it just slightly is much different when you have it in draw mode, and the forces that apply. And in order to get this is a dynamically a friction that is designed to be dynamic, so it changes as you open the kickstand. You don't feel it because you're pushing on a different lever. As the lever arm changes, so to say, the forces adjust. And it just took a whole lot of. The concept was there pretty quickly, but to make it perform like this just took an endless amount of time. And so then finally in Surface Pro 3 we could make it, and so that was pretty nice. And besides just having a kickstand that opens up to 130 degrees, 150 degrees. What we achieved was we have this mode that we call draw mode. Another element that we kind of nurtured along was a pen, of course. Every Surface comes with a pen, and it's interesting because we all come from a mouse and keyboard culture. We have we grew up on Windows and clicking folders, and all of a sudden you have this touch thing that comes in. And with Windows 8, you go like, oh, touch thing came in, maybe it came in a bit massive. But what also came in was the ability to draw on your device, right? Use it as a canvas. And for me, and it's a very, it's been done, pen computing and things like this have been done, for quite some years. But the kind of adoption and usability of these systems are right now just about to come to the point where you actually can compare them with a pen. And if you think about what you do with a pen and paper, it's quite profound what we all do with our note journals, Moleskine books when we go and take notes. And for us, it was very important not to only have a tablet that transforms to a laptop, but then go one step further and have some sort of clipboard, effect or drawing mode where we really build a stage for the pen to interact with the software and then enable things, in that space. And you can just imagine, if you have, a person delivering a package, someone filling out a form, someone taking notes at schools, there are these rich spaces where a pen makes a lot of sense. Right, and this is one of, when we launched Surface 3, we created this picture, and it was really all about, enabling people to put their thoughts down, on digital paper, right, instead of typing it and doing it kind of the traditional way. All right, so the next, I thought I'm going to show all the products that we're developing now, all the top secret ones, but then I wasn't allowed to, so I apologize. But I talk a little bit about what kind of fuels us now, as we've done 3 generations of Surfaces and where our mind is, and as how we look at computers for Microsoft, right? And so that's this whole thing. And one part of it is it's exactly how we started out. There's this line, to have people do what they love and get done what they need, and it kind of sums up what we were trying to achieve with Surface, and I think we're still trying to achieve this with everything that we are developing right now, because it's like if you want to touch someone's heart as a user, and if this is a business person or if this is a consumer, and it's kind of all blending away. But you want to pick up a device that viscerally tells you here's a device that is made from quality, right? Here's a device that I can put all my stuff in, and it doesn't break, it's not too slow in a year, and it gets me to all the things that I need to get to. Many people use Surfaces to get the job done, to give them the money to buy products like this, right? So it's not a tool that you buy for consumption, it's a tool that you buy to go through your busy life and get stuff done, right? You write your papers on it, you write your reports on it, you can sketch your next ideas, but you also wake up and have your coffee in the morning and browse the internet, right? And then you and then you look at your emails, and then you go and answer some, and it's in this whole flow, weaving through your day with this product, and make the product kind of dissolve in that day, and make the product go away because all you're interested in is the software that you want to use, right? And so that's what we are still about, dissolving in behavior, if you want. And so if you think about this, it's an awesome problem, because you want to do this, and then you're entering these two vectors, right? One vector is the vector of technology, which is super fast and always changing, USB-C and all these things, next generation of processors and operating systems and stuff like this. And then you have the vector of people. My mom is still catching up with the first generation of Surface, right? And so the insight is that people don't really want to go and jump on the next new thing and take the class on learning this, right? So one of the most famous American designers, Raymond Loewy, said, "Most advanced yet acceptable," meaning you push to the next step without losing the people who are in the now. And that's an important continuum, right? Because if you buy this super nice new product, and you cannot use your Logitech mouse or your Microsoft mouse or whatever accessory you have that you really like, you lose someone, right? Or you ask someone to buy adapters and things like this. So for us, one of course, the icons was put a USB port in. We had a huge discussion. Of course, aesthetically, oh my God, it's this big opening in the device, and how can you do this? But then you look at people, and they just have a whole bunch of stuff that plugs in through USB, and you don't want to go and leave these people behind, right? And so it's managing everyone to this next level, and while they use your product, have the greatest amount of fun and the greatest level of productivity. So those are two very interesting vectors. And now there are two other vectors, and they are important when I think about design, but I think also they apply to so many other things. If you design an app, right, for example, there's what the app does and how it appears, right? So there's on one vector there's the content, what the product does, and on the other one is the expression, right? How it comes across, how it feels, how it behaves while it does it. And for us in the team, it is always finding that balance between what you want to do with it and how you do it. And in there, it's a bit esoteric, but in there is the choice of going to magnesium and investing a mountain of money in order to let 30% of the weight out in order to reach this fitness, right? Or for us, it's because we want to go and have better products, we invest in a gazillion amount of money to buy all these CNC machines in manufacturing just to get this product a little bit better. Why? Because when you walk into a Microsoft store and you see a Surface and you pick it up, the emotion that it radiates and gives you a preview of how this product will be in your day, it's super important that you get this expression. When you buy cars, how the car door closes somehow talks about how the engine is crafted, how much passion and how much attention someone put on these details. Of course, you can cheat with car doors, but it's very hard to cheat with products that are so light and packed in with, full with electronics. Every time you make a change, everything else needs to change. So those are two very, very important things. And especially if you're talking to an audience like this, productivity is always a big topic. And productivity is an important topic for us as well. When I was in PC hardware designing mice and keyboards, there was a mindset of productivity. Productivity meant, the ARC mouse, that's not a productivity mouse, that's kind of a mobile user mouse. And the productivity mice were the ones that were on the desktop, and you have palm rests for your keyboards. Because back then, people are productive, sit in offices, in cubicles, and then they go and punch away on their keyboards and do away with their mice and on desktop on these beige computers under their desk. But then just think about now, that has completely dissolved, right? The computer has dissolved into all these different things. Many of these computers that we use mostly are in our pockets, right? And so we go through the day with our phones. And so productivity has changed as well, and it has changed in a big time. If you walk into a power plant and you have, and you can take a picture of the situation that you have to go and fix, and if you can get immediate information on what the right valve is that you need to go and exchange, or whatever the problem is. If you go in a hospital and you go to a patient visit and you explain a certain situation to the patient and you can bring the data to the bed instead of bringing these big monitors that are all that scary, that makes you all of a sudden super productive. We had a physician talking to us about how they go through their day, and by being able to plan and bring the data to the patient using a Surface in this case, how much more time they would save for themselves and how much more patient time they could generate, which was super valuable for the patient, obviously. And so anyway, so if you think of productivity, we've zoomed out there, but we had a bunch more crazy slides in this presentation than this. But this one I thought I liked. This is an algebra sheet from a 7th grader, I think, right? So good math, learning, and then but just notice the doodles, right? And so I was intrigued by this thing, you go about your math and then your mind wanders off and you have a good idea. And this is, very similar of how we work in our design team. These are all our, sketchbooks. This is cool. Someone should fix that. These are all our sketchbooks that we had in the first generation, and it is so powerful to use them. This is in context of design, but then people who write software, people who are creative in their minds, and including everyone who has to solve problems. A sketch is able to capture an unfinished thought, right? So this is the earliest sketch I could find in my sketchbook from a Surface, and it's kind of wild looking at it now. But it's this thing, you doodle around and you come up with this idea, and then you move on and have a couple of other ideas, and then you come back to the sketch and add to it, and you can go and express a thought with a pen. And that is not very precise. Imagine you have to express the content that you see here with a keyboard. It's kind of hard, right? You need to be a poet in order to kind of capture unfinished thoughts, but not many of us are poets. So a pen, I think, it's super powerful. And so as we are thinking about our pen, there are also these two vectors, and one is, we call it super normal. Why can we not put the pen inside the device? Why can't we have a super small pen, right? The stylus. And we went through this and thought, what is important to us? And we came to this point where we said, a pen for a Surface should be a pen very similar to the pens that you had all around, right? It should have a certain diameter, should have a certain weight, and it should feel super great when you go and put it to the screen and write and draw. And we put a ton of emphasis and detail engineering on how it feels when the pen writes on our glass, right? One of the things is that we always have we have the best screens in the industry, and part of what this means is that the cover glass on top of it, needs to be smooth. And now we're designing the little black tip that you see there. We've put an enormous amount of energy into finding the right material and manufacturing it in such a way that it gives you a certain amount of friction, and it balances. And then if you get into that, you find out that, there are people like me who draw, who want to have a pen that is rather fast, and then people like my boss, who is a writer, who wants to have this pen rather slow and add some friction. And this might sound like a trivial detail. We spent weeks and weeks and weeks talking about it and making prototypes and trying things out and having really energized meetings about it. My boss Panos is a writer and I'm a drawer, and so I draw, and so we ended up with something that fits right in the middle. And it's kind of nice because it kind of spans, almost like an HB pencil. It spans a wide enough spectrum because people do very different things with it. So for us, it was extremely important that we got the best writing feel on the hardware, and that the pen has a diameter that is ergonomic and you can write for a long time, right? If these instruments become very small, you can do short bursts, like notes and stuff. But if you want to write an essay, or if you do drawing, if you're designing on it, it needs to be thicker. So we designed it in a size that it's a normal good ballpoint pen or fountain pen. And the big advantage is that it doesn't leak, so you don't have to have your pocket protectors with you, right? But then if you think about it, then there's this superpower, and it's very similar to digital cameras, where when we all had these SLRs, and we took pictures and we brought them to develop them, and then a week later someone picked them up after getting the groceries, and then you look at these pictures, right? But now when digital cameras came around, you instantly could see them, right? And the first digital cameras were kind of low quality, but they were good enough because you could do things with them that you could not really do instantly with a physical or a chemically produced picture, which was you could email them, right? And so things like this. And there was some sort of a superpower that we added to cameras, that just the experience and what you could do with them now was just so much bigger than what you could ever do with your chemical photo. And very similar things happen with when you take a ballpoint pen and you make it look and feel and behave just like the ballpoint pen, but the marks, the notes you do, the sketches you draw, they're all of a sudden digital, right? They can be instantly synced to your colleagues. Notes can be taken and translated automatically into text and written out. You can take it, you can go and find a website, maybe annotate, snap it out, and then send it to someone, right? The intuitive power that sits in the ancient tool of a pen, combined with the superpower of being digital, is just a great value, right? And so you'll see us continue to explore this and continue to build experiences around this, because I think pen is much older than the typewriter, and I think it deserves to move into the digital space and give it some horsepower and make it awesome. And we listen a lot to the feedback, right? So you go like, oh, you cannot really store it in the device. Well, even if we had a stylus, there would not be enough room in the device. Not even a toothpick would fit into our device because it's all kind of packed, with electronics. And so we chose to make it this size, and then now we constantly think about how do we make it better? How do we make it better? Another one on this one, just one more thought on the pen. When we designed the pen and had all these thoughts and went about it, we came across, if you have a good idea, if your spouse calls you and say, hey, here's a list on your way back, go to the supermarket, and if you have a Moleskine and a pen ready, you're ready to write your notes right away. Or if you have a good idea. But just imagine you don't have your pen and paper, you have a computer, and then you have your good idea, and then you press the on button, and then you log in, and then you open the application, and so by then the switching cost is so high that it may not be worth to write down the brilliant idea you have and later on you forget. So we had this idea of, why wouldn't you just go and click, just like opening a ballpen pen, and you get to OneNote. And that was a very interesting experience for us. We prototyped it into our studio, and the people who came in were very inspired, and then we collaborated with OneNote to get this feature done. And it just shows for me, it shows a point that if hardware as a stage should kind of fall in the back and should not be there when you're in your software, but at the same time, hardware enables software to happen. The usage of OneNote went through the roof on Surface Pro 3. Why? It's the same OneNote that you have on any other computer, but you can click on it and you be there, right? So we designed a shortcut, like in IKEA when you just go straight to the kitchen, straight to the restaurant. We designed an experience in hardware that creates a path for software, right? And so these intersections are incredibly powerful, right? If you have a vision as a company, you know what you're after, do what people love and get done what you need, you can do an amazing job with the software, the best job in the world. But then if you only do software, you're always behind glass. And that's as far as it goes, right? But then just imagine you extend that idea, go one step further and make hardware, and then really build a bridge to bridge it to the people who use it, right? Because since we cannot plug the internet in our head, there's still a physical bridge that everyone needs. Everyone needs a device in order to get to their digital stuff, and I think that's what we do. And sometimes most of the time we want to make it go away, and often we look for these experiences we can create with the with a special feature like we call it Click Note. School backability. You guys have maybe heard of Labability, right? And we wanted to put a Wikipedia entry because this word didn't really exist, and I think Wikipedia didn't let us. I don't think it's in there. But so school backability was we launched Surface Pro 3 and we were happy with it. And then we thought, well, there was a Surface 2, we should make a Surface 3. And what's the essence of that product versus the Pro 3? Well, first of all, happy are the people who have the money to can afford the Pro 3, right? But so not every high schooler, can go and shell out that amount of money, right? And so part of the idea was, let's go and make a product that has the same essence of the Pro, but it is for the rest of us, right? To be the high schooler, you send your kid to university, and something that you can get your job done, and you can also do what you love, kind of the same principles. And so out came the idea of making Surface 3, and Surface 3 was an exercise of what can we remove to make it fitter for the people we had in mind, right? There's a mobile workforce. You have a fleet of people who go to a customer, fixing things. They don't need the horsepower of a Pro, but they need to have a full PC that is connected, that is also small enough you can throw in a bag, has a long battery life, it's light and thin, and all these things. What applies to the fleet of customer-facing workforce that you have also applies to high schoolers because they kind of live in the same usage pattern, right? That also applies to a nurse in a hospital, right? And so that there is the space where the attributes of what we look after in Surfaces apply to a huge amount of people, but they don't need to have the workstation, right? Our engineers in our team and our designers, they need the professional one because they actually go and run, CAD and the movie makers and people who do photography, professional photographers, on site. They need the processing powers. There's always the space for the Pro, but this one was for the rest of us. And we recently launched it, as you probably hear, and I brought a video that is little. We call it the sizzle that introduces it. That was my last slide. So I guess I don't know if you have questions. I'm not a tech expert. I'm a designer, so don't ask me tricky questions.
So you go through and talk about the past, the present. You missing the third part?
The future, the next, right? There was the next.
3.1.
Oh. If we design another Surface, should it be called 3.1 or should it be called 4?
What are the plans going forward?
The plans that are going forward are, as I said in the slide, it's continuing with the vision that we are on. Making the best hardware that we can make. You've seen how much we got funding. We built ourselves a huge development center in order to go and work together and make things better. And we've been busy, quite a bit. And the vectors I was talking about, right? So technology always moves forward. There will always be the next generation of processes. There will also be the next generation of innovation that we will come up with as we understand the materials that we make, as we get further in refining the things that we have, or as we get completely new ideas and go and apply them with the same rigor that we have. So I think, even though I cannot really tell you what exactly we're going to do next, but you should all, stay tuned, because, I think we just got started. Over here.
So, continuing with that question, so far we've seen a new surface every year. Is that going to be the trend going forward?
That's actually right. Yeah, and so we don't really commit. We release a product when it's ready, I would say, but we also don't work in a vacuum without a schedule, right? And so it's because if you think of if you look at the patterns of technology, there's a rhythm of, let's say, how processors get released, how technology gets ready, and kind of if you want or not, you're always on this kind of pattern of here it makes sense to make a product, right? And so this is how we look at it. We look at where technology intersects to make a product that is worth having, right? So because you don't want to ship right after you ship the Surface 3, you don't want to ship a whole another thing that you now need to go and upgrade on, right? So you don't want to leave the people behind. When I said what users and people need, nothing is worse than buying a product and then a few months later, whoops, it's the next one comes out and sorry, right? But then so we also don't want to lag behind, technology, and so that's kind of the pattern we're looking at, without giving exact dates of when we ship next things.
So when you're talking about the design of the pen, I like the pen, but have you found that the nib wears out because there's a friction point, and have you experimented with alternate nibs?
Yeah, we have done a huge exploration on pen tips, and that's what you mean, right? The pen tip.
Would it be possible to use different width nibs because you do feel the friction, right?
Yeah.
And also, do they wear out?
Yeah, and so we've been testing a whole ton of pen tips, and for us the most important part was that it feels good. Right, and so then, just like a pencil that needs to go and sharpen, well, it's a bit more effort to go and exchange the pen tip, right? So we ended up at one that had the best feel, and we have been continuously improving the wear of it, right? But it's kind of in the materials is if you use it a lot, you need to go and replace it once in a while, just like it's just a part that that gets used. There's physical abuse, on it, and so you experience this. But for us, was not making the longest lasting one. For us, it was important to make the best one that feels the best. Over here.
Congratulations on the launch of Surface 3.
Thank you.
I have a question on the keyboard. I was curious, what kind of feedback have you received on the keyboard from previous version, and is the Surface 3 keyboard different than the Surface Book 3?
That's a good question. If you have followed us from the beginning, we started Surface out with a pressure-sensitive, cover, and we launched this in the first generation. It's still available on the second generation, and there's a huge fan base around this because it makes a super thin keyboard. What we found was on the physical keyboard, the ones with the scissor mechanism, that it aligned much better to getting your stuff done. It was a great productive keyboard, and so we constantly receive feedback. It's a full-size keyboard, meaning from an ergonomic standpoint, there's a certain kind of center-to-center key dimension that we measure, and it aligns to that. There was, just as everything always gets better as we do things, we found improvements. The next generation Surface 3 has modifications to the top coat of the key. It's much more reliable. You wouldn't see any shiny edges, and we improved the scissor mechanisms to make it quieter and things like this. So we've been receiving a ton of input. We also do a lot of ergonomic studies. We have an ergonomics lab where we can just go and test out, how things perform in a lab condition, and how people actually how the fingers land on keycaps. So we continuously push these things forward. Obviously, you also want to create a keyboard that is extremely thin, and a device that is extremely light. And when I talk about fitness, it's all about finding the right balance point, right? And you will see us adjusting that balance point as we get feedback, from people, from an audience like this, or from just visiting people, at schools, at work, at home, and getting feedback. One of the feedback was that we moved into Pro 3 was this magnetic support that we built into the screen, right? And the feedback that we have now is, sometimes it's very hard to hit the bottom row, right? Especially as we know, probably many of you people go into Windows 10, and the bottom row, is more pronounced. It's not that you cannot reach it, but it's like people notice that, they kind of touch the edge of the keyboard as they hit it. And so we get a ton of feedback, and we take it super serious, right? And so we constantly then try to go and adjust and explore, because on the other hand, you don't want to lose that magnetic support, right? And so finding and that often this stuff describes an awesome engineering problem that we then all go and solve. Yeah, there's a Surface app that we have you can download where you can adjust the pressure sensitivity, and so there's a slider, and then right next to it there's a field where you can try it out and dial it into your liking.
Yeah, but that fixes it to one sensitivity.
Uh-huh.
Like with the PPI, the set fixes.
Yep.
You can actually paint, and based on how much pressure you put on the pen.
Yeah. Right, so we have, no, I don't know the number, I think over 1,064 or so pressure levels, right? How much? What? 1024 was close. So of pressure levels, which would do the same thing.
So when you started with a team of 8, I'm sure you were all incredibly focused and dedicated to this project, and as you've scaled out to more and more people, how do you keep that feeling of a close team and that hyper-focus on the project?
Okay. Let me look here. Okay, we have 4 minutes left. The last person who asks a question, I have a Surface Pro 3 I can give away. Well, you're not there. See if you're the last. Okay, so when we started out with 12, so there was this culture that you create, and it's a phenomenal insight actually, and I think it's phenomenal insight for anyone who works in any corporation. You walk into a company and there's a culture, and the culture grew over time to whatever it is. And it was a huge advantage for us to start really as a garage startup. Well, was this garage startup inside of Microsoft, and then we had to figure things out, right? And so there were the values that we created and the culture that we created led us through the first 50 people, and you could kind of organically, people would come in, they would kind of figure out how does the Surface team work, and then they would adjust. What happens is then you grow larger, and we are super busy, right? If you get hired on, let's say, as an engineer, you would come in from the company wherever you worked before, and you would be thrown into a project, and it's all busy, and you need to go and solve problems. What happens is you use the tools that you bring from your other company, because that's what you're used for, right? But that's what you're used to, and try to problem solve like this. But Surface works very different, right? It is not the values that we have of having perfect products, fail fast to succeed sooner, right? No, we don't want any cynics, right? We want we often talk about grab an oar, and work, and get to work, help your team, see what you can do, help out, right? And so these are not oftentimes these values don't match with with other companies, and so you need to go and adjust to them, right? And so what we've done is, as a leadership team, we've paid a great amount of attention to how do we cultivate these types of values, because if you come into our place, you have no idea how what's the right thing to do in this situation. Is it scheduled? Is it cost? Is it product features? And and there needs to be a decision, and my job is on the line or not. And so all these things that you ask yourself as someone who comes into our team. And so we've been working on talking about these values that we have to bring people along, to get them kind of calibrated on this is important to us, and it works really well. Because once you understand what the team is about, that we have a vision, and we actually really would not let go on this feature, right? No, I really want to have this feature, right? And we should go and really prototype it out, and kind of this relentlessness and how it's actually practiced is something that we're trying to go and teach the great talent that we hire, so they rather fast kind of see what's the flag that what's the flag we're running at. We get rewarded by making the greatest products, and not by playing the safest game, if you want. So many hands. All right, there's the red light that comes up, and the guy who kicks me out. Let's say the gentleman over there in the red. Yeah, you.
What kind of extracurricular activities or things outside of work do you participate in to help inspire you for your product?
Oh, okay. Well, I have my family. I have two teenage daughters, and 13 and 17, and oftentimes sometimes I bring unreleased products home and say, hey, check this out, and they're the harshest critics. It is. This is very inspiring. I also spend a lot of time mountain biking with my friends, and this is kind of in the woods for hours, going away, not being connected to any technology, and just like go and be off. It's a great way to recharge, and whenever I can travel to cities like Chicago, or others, it's very inspirational. I think you need. I'm trying to have enough time off, because if you're just at work, it is. It kind of screws with your mind too much. Over here.
How much of what you do is influenced by what other manufacturers are doing?
Not much really. I think we all take competitors' products, we take them apart and understand how did they make this, how did they make that. But I don't really look at the competition. We have we have an idea and we're trying to make it, and oftentimes we try to understand how other people manufacture stuff, because it's good learning, but really not much. We're trying to do our own thing. Yeah. Surface Pro 3. Let's see over here.
Unlike the other hardware manufacturer that took all of the exterior USB ports off, are you going to continue using USB ports, USB 3.1, USB-C? Is that you're going to adapt your power input to be USB 3?
Yeah. So it's this intersection of technology advances, and you don't want to leave people behind, right? And sometimes, if you see with our pen, we are the innovation makers, right? Because we introduce a technology that we really believe in, and then we cultivate it so people can adopt it, right? This is new to the world stuff. But on a thing like a USB port, where people have just a whole bunch of things, we don't want to leave them behind, and there will be, of course, an intersection where we move on to the next standards, right? But this move is going to be done with a lot of care, looking at how much people have invested already in this, in their either surface accessories that they have in their businesses, or the stuff that they have at their home, right? And so making sure that we don't go and mess this up. So if you have just invested in a whole bunch of, I don't know, let's say docking stations, right? It's important.
Is there a special reason that the magnet for the pen device is on the right side and on the docking on the left side? Because I always switch sides.
Okay, say it again.
The magnet for the
Yeah.
on the device is on the right side. Why is it on the docking station on the left side?
Ah, okay, okay.
Special reason for it?
There's actually what you see with the magnetic force for the pen on the device side comes from the charging magnets. So they were not designed to hold the pen. Even the steel in the battery, holds it, and it was purposefully designed in the docking station on the left. But it's a great observation. Okay, last question.
Have you closed the keyboard connector? Is that proprietary, or are there just third parties aren't stepping up? Is that Microsoft that's preventing other manufacturers from getting access?
The keyboard connector.
I always felt that I could design a more laughable keyboard.
Yeah.
For certain situations.
Yeah.
Playing and things
Yeah.
like that, where you just don't have kickstand room.
Yeah.
I just wonder why no one else has done that. And whether
Right. So it's a connector that we develop in-house, right? So we own the IP, and I'm not quite sure how we go about it. I think there should be ways of like how you go and tap into this. This would be a great thing to follow up with some of the technical people here to figure out if you can go and use it. But I would be surprised if you couldn't. Okay, one last question.
We're going to see LTE on the next Surface Pro. We see it on the Surface, but are we going to see it on the Surface Pro?
I don't know.